we're never gonna survive unless we get a little crazy.
Hey YouTube, Dan here. Thanks for coming back. Today we're going to discuss the Kalam Cosmological argument and the problems I have with it. First off, what is it? What is the Kalam Cosmological argument? Well, we'll take the Kalam part off for now and just discuss the cosmological argument. Aristotle proposed a syllogism, a logical statements leading to a logical conclusion. The first statement was this: everything that begins to exist has a cause. Second statement, well, the universe began to exist. And the third logical conclusion, the universe has a cause. Damn that Aristotle. I like the way he thinks. Logically straightforward, and given that you accept some of the definitions, it's a pretty straightforward statement. Things that can be discussed are, what do you mean by existence? What do you mean by begin to exist? And I know that some of these are the finer points that they talk about, but I had a discussion about a month ago with a gentleman regarding this. Now, he was a theist, Christian, I believe, and he wanted to bring in the Kalam cosmological argument. Now, Kalam is an Islam tradition of Al-Kalam, which is discussion, discourse, learning and discerning theological elements through argument or discussion. So the Kalam cosmological argument, I believe, is put in place to explain why Allah is the original source and cause of the universe. Now, there's Christian apologists nowadays that use the same thing, same argument. I don't know if they refer to it as Kalam argument or if it's just the cosmological argument, but William Lane Craig is one of the proponents of this argument. And he explains that, there is a cause for the universe, and he believes it is a benevolent, omnipresent, omniscient, omnipotent being that has vested interest in our well-being and a plan for the universe. Now, that is one hell of a leap from the universe has a cause. And the gentleman I was debating with a month ago was using the same arguments that William Lane Craig does. And he was saying, well, the most plausible answer is, of course, a being that created the universe. Well, there's a few discussions that were going on with this gentleman, and people were saying, well, what created the universe? This being. Well, what created that being? And the answer was shocking, because if you want to say anything that exists has a cause, well then bam, you get to say God exists. Well, what created God? The magical purple fairies. And then they go, oh, no, that doesn't apply. Our God was never created. It always existed. And there were some other discussions about, can you create something finite from something else that's finite? Like if I had two ducks and I wanted to create a third duck, I can't just take pieces of two ducks and make one. I have to have the materials for it without destroying the initial ducks. Something to do with the law of thermodynamics and the conservation of energy. Fine. So you're saying that there has to be a magical creature over here that has enough power to create a duck without the components of a duck. And you couldn't have done it with the energy we have from a duck or two because it wouldn't work that way. Fine. Now, the argument I have a problem with is that if you can make the exception for your God that he was not created and always existed, then why can you not apply that to the universe itself? Why the extra step? It seems to me that this kind of logic is a lot of the same type of thought process that, religious people will use to explain the belief in their scripture. How do you know the book is divine? How do you know it's divinely inspired? Well, it's the Word of God, and the book says that it is true. And the book talks about the Word, and the Word references the book. It's kind of a circular argument, but they take the same leap of faith. Well, my God cannot be created. Therefore, the God was the cause of the universe. That makes no sense to me. The universe should and would have the same attributes, infinite, most powerful. How could you possibly create all the energy we have? By having something that contains all the energy we have. Very, very straightforward to me. Now, in discussing this, there's a few things that I tried to think about. And I came across another discussion, a talk by Brian Greene, a really smart guy, a theoretical physicist. And he was explaining his ideas about the universe and how to explain it. And maybe some possibilities as to why our universe is like it is, and is it the only universe there is? I love this discussion because he goes through and logically explains a couple things. The first thing he does is pull out a constant, a measurement of energy that he believes is everywhere. And actually, there was a Nobel Prize given to the gentleman who worked on this because they had some questions. Edwin Hubble proposed that he measured the redshift of the light from distant galaxies, and he realized that the further away the galaxies were, the more redshift there was. And what that means is they are traveling away from us faster than things that are closer. Now, usually that wouldn't be a problem, but it kind of goes in the face of the static universe. Einstein initially thought that there was a static universe and it didn't have to be changing all that much. We could use the laws of motion to explain just about everything. The theory of relativity had a lot to say. Well, the measurements of this light by Edwin Hubble explained that things that were further away from us were moving faster than things away from us than things closer. So the expansion of the universe was increasing in speed. Now, the Nobel Prize was given because these guys were trying to measure how much the universe is expanding and how slowly that expansion is slowing down, because they figured, based on the gravity we have, the universe will expand and all the matter will attract again back to itself. And they wanted to find out how much the universe expansion is slowing down so they could maybe calculate how long we've got left. Turns out they didn't find that it was decreasing in speed. They found it was increasing in speed. The expansion of the universe was getting faster. Now, Brian Greene goes to explain, in order to establish this type of measurement, they had to go and measure distant galaxies and find out how fast the older things were moving away from us based on the light. And they found a very minuscule amount of energy required to push things apart. Now, usually when you think of gravity, you think, well, gravity pulls things together. The mass of the planet, the mass of my body, the distance between us, that shows how gravity works and how much the pull is. Well, Einstein also, in his theory of relativity, allowed for gravity to repulse things. And what it would do is there would be not a field, but a saturation of energy. If there were a saturation of energy, it would actually allow for gravity to push everything away from everything else. Now, this saturation wouldn't have to be much. And Brian Greene showed that based on this measurement of light that they had, they could calculate exactly how much energy or mass would be required to push the galaxies apart at the speed that they are increasing. Well, there's some awkwardness there. How do you see matter you can't see? Well, Lawrence Krauss explains that through measurement of galaxies, we can tell the mass of a galaxy and the density of a galaxy and what holds it together. So when they talk about the spinning stars and planets in a cluster that go around each other in a galaxy like the Milky Way, he says, when we looked at a galaxy, we could not account for all the mass. We looked at the stars, we looked at the light, we looked at, potential black holes at the core, and we could only get a certain amount of percentage of what we needed to explain the mass of that galaxy. And then they came across a weird little thing called gravitational lensing. What it was is when they looked at light at a galaxy, they would see these blurs around the edges, and these blurs were actually more distant galaxies. Very interesting, because they were able to extrapolate and take the visual images and mathematically adjust them to discount the lensing, the gravity of the galaxy in front. And when they did that, they got a good picture of a galaxy behind it. But they also understood, based on the amount of lensing, how much the image was stretched. They could tell how massive the galaxy in front was. So when they looked at the measurements and they took out the math and they used some reverse extrapolation to get a good picture, they could tell how much mass was in that galaxy. But when they looked at this galaxy directly, they couldn't account for all the mass with what they could see. So they said there has to be some other mass, a form of energy, a form of matter that we just can't see. If you've ever heard of dark energy or dark matter, this is it. This is also the same thing that they were measuring when they talked about the expansion of the universe increasing. The dark energy required to allow for that to happen. So when you talk about Brian Greene's discussion, he brings up some interesting topics. He says, well, here's this measurement that would be required, and it seems to be pretty unique to us. And he says, if this amount of energy were different, we would see that the universe actually would slow down and collapse again. And there are many constants in the universe that explain or have similar behaviors, like gravity. If gravity's pull were a little different, let's say gravity's pull were less, in the beginning of the universe, when the matter started coalescing, you wouldn't have enough gravity to coalesce. You wouldn't have it. And if the gravity was too strong, it would wrap everything up and bring it in too tightly, and you'd end up collapsing everything into black holes, and all the matter would be gobbled up. So a lot of constants like this are going to end up being very specific for our universe. But Brian Greene explains, well, what if we have to use math that really can't explain everything? Well, we have a pretty good theory together right now called string theory. Einstein didn't like it, but it's based on quantum physics. And it's supposed to be a theory that ties together electromagnetics, gravity, and the quantum world into one basic theory that can elegantly describe everything we can see. Big aspirations, I got it. But string theory does account for and allow for additional universes. In fact, it subscribes to more than one universe. And if we think about that, and we talk about the math involved, and how many different ways we can explain that this universe is in one particular shape, it really lends to some deep thinking. Because Brian Greene explains that maybe the way our universe is the way it is because it's the only way it could be. Any of these various settings that are tweaked to be off a little bit, and matter wouldn't exist. How would we be here to ask the question? Anything tweaked to temperature-wise, distance from the sun, why are things the way they are? Because it's the way they have to be for us to exist. Now, I know that's a simple explanation, but in other universes, gravity is different. They don't create matter. And actually, he was going through to explain possibly that there might even be a way to detect other universes that may have bumped into us, and they're working on that. But I find that if you can explain the creation of the universe, or you can blow off the creation of the universe and explain it as the will of some sentient being outside the universe, I find that that's really, really a discussion that doesn't need to be had. If you want to present evidence for why you believe that, go ahead. But logical conclusions don't always equal answers that are feasible. Now I'm going to give you an example. There are other syllogisms. Every dog on earth dies. George Washington is dead. George Washington is a dog. Now, taken out of context, that can be a bad syllogism, bad logic. But you can see how a logical statement cannot be carried through to fruition if it doesn't hold, valued and consistent definitions. So when you talk about the Kalam argument, you have to deal with existence and begins and contingency. And those things all seem to be wrapped up into the same default answer of, do you believe this could be the case? Because the logical statement says the universe has a cause. But it also is predicated on the fact that the universe began to exist. If you don't say the universe began to exist, then it does not require a cause, and it can be as eternal as the God that you want to say created it. Either way, very interesting discussion.